Okay, so we're recording. Okay. All right. Just one moment here. Let me pull up the syllabus. Okay, so can everybody see my screen, the syllabus? You should be seeing it now. You could also pin me to the screen in case you don't see it. Okay, great. All right, so the syllabus is on Blackboard. Also, for the future, any announcements for the class, anything like that, will all be posted on Blackboard. Okay, and you should also hopefully get emails from Blackboard whenever I post an announcement. Okay. All right. So let's go through this. So again, my name is Stephen Goldman. If you ever need to contact me for anything, you can email me. You should use the email address here, sgoldman@qc.cuny.edu. If you ever want to make an appointment, that can be done through email as well. Okay. The textbook that you will need for this class is Discrete Mathematics and Its Applications by Kenneth Rosen. I'm using the 7th edition. I suggest you use the same, just so that when I assign homework problems from the textbook, the numbers will be the same. If you have a different edition, that's fine. Just to, maybe check with somebody, maybe one of your classmates. You can check with me to make sure the problems are the same. Okay. All right. If you can find that if you can find an online version or a digital version of the book, that's fine. As always, try and see if you can find the least expensive version. Okay. The class schedule, I'm sure you're all aware of. We'll always, as I said, meet at this link on Google Meet. This course, discrete math course, it's going to cover a lot of ground. It covers a lot of different subjects, sort of a hodgepodge of different things. We're going to go over throughout the semester logic, sets, functions, a number theory, combinatorics, and introduction to proofs. Okay. This semester, this math class is probably going to be a little different from other math classes you've taken. A lot of the subjects we cover tend to be a little bit more abstract, and there also is a lot of discussion of proofs. Okay. Somebody asked, there's an 8th edition. Should we try to get the 7th if we can? I'm using a PDF version. Either version should be okay. Like I said, I'm using the 7th edition. That's the one I have with me. So if I would recommend you get the 7th edition. If you have the 8th edition already, that's fine. That's perfectly fine. Okay. Okay. All right. Homework will be assigned from the textbook as well. All right. That's why generally it's good to try and have the same edition, because sometimes different editions will change some of the homework problems or change the numbering. Okay. The way your grades will work will be as follows. Okay. So there's going to be 3 exams in total. All right. Exam 1, exam 2, and a final exam. Each of those exams will cover 20% of your grade. Okay. There's also going to be some quizzes throughout the semester. There will be 5 quizzes, and that will also be in total 20% of your grade. And then there's also going to be a writing assignment, which will sort of be a research project, okay, which I will post on Blackboard for you. Basically, the way it will work is I will give you a list of topics to research, and you would choose whichever one you want. You'll research the topic, and you write about a 2-page essay or something around that on the subject that you chose. Okay, and the grading rubric for that and the details of that will be posted on Blackboard. Okay, and that will also be 20% of your grade. Okay. Any questions on any of that so far? The homework that I will assign to you will not be collected. That'll be for you to do. And then at the next class, if you have any homework problems that you'd like to go over at the beginning of class, I'll ask, and we can go over the difficult problems that you had trouble with. Okay. Somebody's making a WhatsApp chat for the class. They made a group for the chat. If anyone wants to join, the link is there. Okay. All right. Okay. I also posted on the syllabus a tentative schedule for the semester. Okay. I also wrote the dates are subject to change, so it's not exact. It really depends on how fast we move. But it's an approximate, it's a tentative schedule of how things will work out throughout the semester. Okay. All right. So any questions on any of that?
Yes. What if like you missed one of the exams? Because from my other class, if you missed the exam, the professor said that the final will like count twice for it.
If you have an issue, you need to miss an exam, then send me an email, get in contact with me, and we'll work something out. Well, most likely what we'll do is we'll probably do a makeup exam.
All right. Thank you.
Okay. Okay. All right. So we have two more questions. Let's see here. The quiz dates. So the quiz dates, they're not set yet. I will give you advanced warning though before each quiz. Let's say approximately every 2 weeks, maybe something like that. There'll be a quiz. Okay. And I'll give you an advanced warning. The quizzes will be will be on Blackboard. That's the way the quizzes will work. Okay. Is homework graded? No, the homework will not be graded. It will not. I'm not going to collect the homework. Okay, the homework problems are for you to do. They will prepare you for the quizzes and for the exams. All right, it's really the best. One of the best ways to learn the material is through doing the homework. Okay. Okay. All right. Any other questions? Okay. Also, let me mention now, I'm going to need to do a verification for enrollment to make sure that everybody signed up for the class, showed up, and participated in some form. So to do that, I'm going to do two things. For the first few classes, I'm going to be taking attendance at the end of class, and also I'm going to ask that everyone please email to me a copy of either your student ID or any photo ID that you have. Okay, so that I can just verify that everybody's was here or participated in some form. Okay. The exams will not be through Blackboard. The exams will work a little bit differently. So for the exams, I will send you the questions, and then I will proctor you through your device. So either you'll have your camera turned on from your computer or your phone, and I'll watch you as you take the exams. Oh, what do we have to email? I requested, I'll post this on Blackboard as well. I just requested that everybody email to me a copy of either your student ID or any photo ID is fine. Okay, and again, I'll post that on Blackboard. Okay, any other questions? So as I said, I'll be recording all the lectures. I will post the links for the recordings on Blackboard as well. Okay. Somebody also posted on the chat here a link for a Discord group for this class, if anyone wants to join. Okay, so the format of the quiz is not going to really be the same as the exams. Somewhat, not exactly. The quizzes will be either multiple choice or short answer, and the exams will be a mix. There'll be multiple choice and also long answer questions. Okay, any other questions? Okay. If there's no other questions, with open video for the quizzes, I won't be proctoring you on. The quizzes will be on Blackboard and they'll be timed, but the tests I will proctor you. Any other questions? The quizzes will be roughly approximately every 2 weeks. There'll be a quiz. All right. Again, I'll give you advanced warning beforehand. No, no pop quizzes. All right. Okay. Oh, yes, the writing assignment will be due by the end of the semester. Okay, on the say by the last either it'll be due the last day of class or it'll be due when the same day as the final exam. Okay, I'll let you know. The assignment will be posted. I'll try to have it up as soon as possible. All right, so I'll give you plenty of time to work on it and to do it. Any other questions? Okay. All right, so if there's no other questions, let's get started. Okay. Just give me one moment to set up here and we'll begin. All right, can everyone see my screen before we begin? Okay, great, excellent. Okay, so the way this is going to work, excellent. The way this is going to work is I'm going to lecture, and as I lecture, I'll write on the screen so that you can follow along. I suggest that you take notes as we go. Later on, once this lecture is posted, if you want, you can always rewind and rewatch as much as you like. Okay. Okay. So we're going to start here in chapter 1, which deals with logic. Okay. And logic and proofs. So just in general, I was mentioning this earlier, this class is probably going to be a little bit different than other math classes that you've taken until this point, okay? We're going to deal with a bunch of subjects that can seem very abstract, and especially with logic, a lot of the stuff will not seem like math stuff. In the beginning, especially, it'll seem like almost like an English or philosophy class. Some of you have probably seen logic in one form or another in your high school classes. Okay, so we're going to start with logic. Once we have the foundations of logic, that will allow us to discuss an introduction to proofs and how to do proofs, which you've also have probably seen in some form or another. If you're from New York and you took the geometry regions, you might have seen a little bit of proofs previously. Okay. All right. So we begin today with section 1.1, which deals with propositional logic. Okay. Yeah. Okay, so we start this chapter with a definition for what a proposition is. Okay, so our first definition. A proposition is a declarative sentence. Okay, that is a sentence that declares a fact. That is either true or false, but not both. Okay, so a proposition is just a statement or a sentence that's declarative. It's declaring something as fact. Okay, so any statement that's a proposition has a truth value, meaning it's either going to be true or it's going to be false, right? But it has a truth value. It's one or the other. It's either true or false, but not both. Okay. So what are some examples of sentences that are propositions and sentences that are not propositions? Let's look at some examples. So the following are propositions. Let's look at our first statement here. Let's say I write Albany is the capital of New York State. Okay. So here's a sentence. It's a sentence in English. It's a declarative statement, all right? And it has a truth value, right? It's a true statement. So this is a proposition, and that's true. Okay, so a lot of times when we want to write a statement as true or false, instead of writing out true or false, we just write it, you have either a capital T or a capital F for its truth value. So T for true. Okay. All right, that's an English sentence. I could also give you a mathematical statement that's a proposition. For example, 1 plus 1 equals 2. This here is a statement. It's a math statement. Okay, that's also a proposition. It's saying 1 plus 1 is 2, and that's also true. Okay, that's a true proposition. Propositions can also be false. So, for example, let's say I give you the sentence, Queens College is in Hawaii. Okay, this is a proposition, but it's a false proposition. So this is a false proposition. All right, so for its truth value, I'd write a capital F like that. Okay. And then again, that was a proposition that was an English sentence. I can also have a proposition that's a math statement. So if I write 1 plus 1 equals 11, again, that's a declarative statement. It's a proposition. It has a truth value. It's false. Okay, so these were all propositions. I can also give you sentences or statements that are not propositions. So what are some examples of things that are not propositions? The following statements are not propositions. I'm going to write props for short. All right, it's short for propositions. All right, so our first example. How are you? Okay. It's not a proposition because it's not declarative. That's a question, right? It doesn't have a truth value. There's no, I can't say about this sentence that it's true or false, and it's a question. This is a question. Not a proposition. It does not have a truth value. Another example of a statement that's not a proposition would be a command. Commands are not declarative. They're not true. They don't have a truth value. So, for example, let's say I told you, do your homework. Okay. That statement is not declarative. I can't say about it that it's true or false. That's a command. So this is a command. It also does not have a truth value. Okay. So those were both English sentences. Let me also give you a math statement. Okay. Let's say I write this down. X plus 7 equals 9. Okay. This sentence as it is also not a proposition. Okay. Why not? Because I haven't told you what X is. All right. So because X is an unknown variable, you don't even know what X is allowed to be. You don't even know its domain. If I gave you a domain for X, what X could possibly be, then you could say that this is a proposition, perhaps. Because I don't know what X is, this thing has no truth value. It's almost nonsensical. Okay. So because X is an unknown variable, the statement is not a proposition. Okay, so unless and until I either I give you some value for X, or I tell you what X is allowed to be, this thing is not a proposition. Okay, and it doesn't have a truth value. Okay. No, it doesn't need to be proven. It's a declarative statement. Okay. Theorems would be statements that we prove. Okay. So if I have a proposition that I've proven to be true, then that would be called a theorem. Okay. Any other questions? Okay. All right. So in logic and propositional logic, we're going to be dealing with propositions a lot. Propositions are going to be the objects that we're dealing with. Okay. So a lot of times, instead of dealing with the sentences, we want to assign letters or variables to represent those the propositions. Okay. So in logic, we use lowercase letters to represent propositions, and we usually start with the letter P. Just like in algebra, we use X, Y, and Z as letters to represent variables. In logic, our variables will be propositions. Okay. So in logic, letters are used to denote propositional statements. Okay. And traditionally, the letters we use are P, Q, R, S, etc., etc. Though you could really use any letter you like. Okay. Okay. We had a question. Do we use theorem to determine the truth value of propositions? It's possible that you might have a proposition that you want to prove is true, and you might have a theorem that you've already proven to be true. Sometimes we use previously proven theorems to prove new theorems. Okay. All right. Okay. All right. So, for example, let's say I have a proposition. Okay, let's say my proposition is the sentence, the sun rises in the west. Okay, this here is a proposition. I can denote this proposition by the letter P. Okay, so every time I want to refer to this sentence, and instead of writing down the whole sentence, I'll just call it P. Okay, so P is, in this case, it's false. It's false. And so we'd use a capital F to denote its truth value. Okay, so let me just write down what we've been discussing truth value for a few minutes now. Let me just write down what that is. Okay, so every proposition has a truth value. Okay, denoted by capital T if it's true, and capital F if it's false. Okay, so we have our basic building blocks here, our propositions. All right, we have these propositions are simple statements. Okay, we're now going to determine, excuse me, we're now going to define ways to create new propositions from the ones that we have. Okay, we're going to discuss different ways to combine propositions to create new ones. All right, and we're also going to introduce different types of operators on propositions. So we're going to start by discussing the negation of a proposition. Okay, so definition. Okay. Let P be a proposition. The negation of P denoted by this symbol here. So this is read as the negation of P, or sometimes it's read as not P, okay, is the statement it is not the case that P. Okay, so the negation of P is a new proposition. All right, it's a new sentence that's also a proposition. It's the sentence, it is not the case that P, whatever P is. Okay, so this is read as not P, as I said before. Okay, the truth value of the negation of P is the opposite of the truth value of P. Okay, so whatever truth value P has, let's say P is true, its negation, not P, will have the opposite truth value. So again, if P is true, not P will be false. If P is false, not P will be true. Okay. All right, so let's see some examples of this. Let's say I have a proposition P. Okay, let's say P is the sentence, John knows C++. Right. C++ is a programming language. I'm sure most of you have heard of it before. Okay, so what would the negation of this sentence be? Not P. Okay, so based on what we wrote above, not P is the sentence. It is not the case that P. So P here is the sentence, John knows C++. Not P is the sentence, it is not the case that John knows C++. Okay. So when we write down this sentence, I initially wrote it down this way based on the definition, but we can actually simplify, right? A lot of times in English, I can say the same thing in multiple ways. It's true almost in any language. So I can simplify not P, right? This is the same thing as saying John does not know C++, right? So, or we can simply write not P as John does not know C++. Okay, that's the same thing. Right? So a lot of times when we're writing down sentences in logic, when you first write it down, it might seem complex, and a lot of times you can sort of simplify it into a more simpler version. Okay. We can also write something called the truth table. Okay. Okay. A truth table is sort of just a table that tells us every possible truth value for our proposition. Okay. So if I wanted to write a truth table for not P, that's just a table that shows me every possible truth value not P could have, right? So whenever I write a truth table, I always start with whatever my proposition is, P, whatever my variable is, and then afterwards I add the operators to it. Okay. So P is some random proposition. It has two possible truth values. It's either true or it's false. Okay, so I wrote down those two possibilities under P. Okay. We said before, not P will always have the opposite truth value of P. So if I go across here, when P is true, not P will be false. When P is false, not P will be true. Okay, so this table sort of just shows that to me. When P is true, not P is false. When P is false, not P is true. Okay, so it shows me every possible truth value. Okay, all right, let's see. We think we have some questions here. Yeah. Yes, exactly. Okay. All right. So somebody had a question before about, I missed it before, if you want to repeat it. For P and Q, you can make variables equal true or false as long as you define them beforehand. Okay, I'm not sure what your question was, but yeah. So basically what I'm saying is if you, for any proposition P, right? Let's say I don't know if it's true or false. Right now I'm just going through all the possibilities, right? P could possibly be true or it could possibly be false. Right now I don't know at the moment, right? What we're saying though is if P is true, then its negation will be false and vice versa. Okay. All right. Somebody also asked about the tilde symbol. Yeah, in some texts, in some places for negation, instead of using this symbol, sometimes some texts will use this symbol for negation. Okay, our textbook uses this symbol here, so that's the one I will use. Okay.
Professor,
Yes.
I have a question.
Yes.
Does it matter if the letter is capitalized, like P Does it matter if it's lowercase or capitalized?
Usually we use lowercase letters. We'll use capital letters for other things.
Oh, so it does matter. So now, okay.
Okay. Okay. Any other questions? Okay. Yes, we're going to get into the other connectives. Well, into the connectives today. Okay. Okay. So far we have a proposition P and its negation, right? We have our first logic operator, the negation symbol. We're now going to discuss what somebody mentioned in the chat. We're going to discuss connectives, which are different ways to combine propositions to create new propositions, okay? And when we do that, we will call those new propositions compound propositions because they're made up of multiple parts. Okay. So the first one that we're going to discuss is something called the conjunction. All right. So this is the definition for a conjunction of two or more propositions. All right. So let P and Q be propositions. P and Q represent two propositions. All right. The conjunction of P and Q denoted by the following symbol. Okay, so it's written this way, and that's read as P and Q, or the conjunction of P and Q, is the proposition P and Q. Okay. All right, so a conjunction of two propositions is just when we take two propositions and combine them into one sentence using the word and. Okay, so that symbol that I wrote, that upside down V, represents the word and. All right, so the conjunction P and Q is true when both P and Q are true and is false otherwise. Okay. So the only time a conjunction is true is when both of its parts are true, when the P and the Q are both true. If one of them is false or both of them are false, then the entire sentence is false. Okay. All right. So let's say we have the sentence, the following propositions. Let's say P is the proposition. Lisa's car has a backup camera. And Q is the proposition Lisa's car has a flat tire. Well, not a flat tire. Let's see. Let me make this a different sentence here. Has, let's say, a sunroof. Okay. Let's say that those are our propositions. So P is the proposition Lisa's car has a backup camera. Q is the proposition Lisa's car has a sunroof. All right. So the conjunction of these two propositions, P and Q, creates a new proposition, and this is a compound proposition because it's a combination of two or more propositions. Okay. This would be what sentence? So this would be the sentence, Lisa's car has a backup camera and Lisa's car has a sunroof, right? Or more simply, I can simplify that to the sentence, Lisa's car has a backup camera and a sunroof. Okay. So let me also write here that, as I've been saying, a compound proposition is a proposition made by combining two or more propositions. Okay, so a conjunction would be an example of a compound proposition. When I'm doing a conjunction, I can also throw in negations into this thing. Okay, so if I wanted, I could write the sentence P and not Q. Okay, this would be the sentence, Lisa's car has a backup camera and Lisa's car does not have a sunroof. So, Lisa's car has a backup camera and it does not have a sunroof.
Professor,
Yes.
what does that mean? Compound proposition is a proposition made by combining two or propositions.
Oh, so I just mean that, for example, this would be a compound proposition, P and Q, because it's a sentence made up of multiple propositions.
What is an or proposition?
Thank you. I forgot the word more.
Oh, I see.
Thank you. Thanks for pointing that out. Okay, good. Okay. You should know whenever I write something, I never make a mistake. I'm just testing to see if you're awake. All right. That's how we check for class participation. Okay. All right. Points to Leo for catching that one. Okay. Or brownie points at least. All right. Okay. I also want to make a point here, back to this sentence we were dealing with, the P and not Q here. So I wrote the sentence, Lisa's car has a backup camera and it does not have a sunroof. Okay. A lot of times in English, if I were to write a sentence like this, instead of writing down the word and here, what word would I use? But, exactly. Yeah. So I could have written this sentence with a but instead of and. So I could say Lisa's car has a backup camera, but not a sunroof. Okay. So a lot of times in English sentences and in the homework, you'll see this. Instead of using the word and, you'll see the sentence written with the word but. Okay, so the word but has the same meaning as and. It means that the sentence is a conjunction. Okay, so sometimes the word but is used instead of and in a conjunction. Okay, so if you see that word, that means that the sentence is a conjunction, okay? And you usually see it in a case like this where you have P and not Q. Right? Okay. All right, any questions on that? Okay. All right, so let's also now write out the truth table for the conjunction P and Q. Okay. Again, the truth table just is a way to visualize the different possible truth values for a proposition. Okay. So anytime I make a truth table, again, as I said before, I'm always going to start with my variables. Here, my variables are P and Q. So I write a column for P and a column for Q. Okay, and then after that, I write a column for the conjunction P and Q. Okay, so if I have two variables, I've got a P and a Q, I really have four possibilities. Okay, either they're both true, that's possibility number one, or they're both false, that's a second possibility, or P is true, Q is false, or P is false, Q is true. Okay, so those are my four possibilities. So I'm going to write out those four possibilities here. Okay, first possibility, they're both true. For the next, I'll write where P is true, but Q is false. For the third, I'll write where P is false, but Q is true. And the fourth possible case is where P is a false statement, and Q is also a false statement. Okay, they're both false. Those are my four possibilities. Okay, and we said before, a conjunction is only true when all of its parts are true. So it's only true when both P and Q are true. All right. So looking here in the first case, when P and Q are true, the conjunction will be true. Okay. When P is true but Q is a false sentence, the conjunction will be false. Right. Third case also, when P is false, Q is true, the conjunction is false, and the same thing in the last one, both are false, so the conjunction, that sentence will also be false. Okay.
Professor,
Yes.
but the entire sentence isn't false though, just a part of it.
Yes, but once I make a conjunction, the conjunction is basically stating, it's a sentence stating that everything in the sentence is true. So if one of the parts of the sentence is false, then that statement is false.
Okay.
It's like if I say my car is like, let's go back to Lisa's car. Let's say I give you the sentence, Lisa's car has a backup camera and a sunroof. Right? I write down that sentence. Okay. And let's say Lisa's car does not have a sunroof, but it does have a backup camera. So P is true, but Q is false, then the statement is false. All right. Let me write that down maybe. One moment. Here. Okay. So using that example from before, right? P and Q, where P and Q were the same as the ones from before. Okay. So the conjunction P and Q is the sentence Lisa's car has a backup camera and a sunroof. Okay. All right, so we've written down this sentence here. Now let's say P is a true statement, so that Lisa's car has a backup camera, but Q is a false statement, so that it does not have a sunroof. So let's say P is true. All right, for the sake of argument, and Q is false. Okay. So then this sentence is false. It's a lie. It's not true, right? Because I told you that she has a backup camera and a sunroof, but the car doesn't have a sunroof. All right. So as long as a single part of the sentence is false, the entire statement is false. Okay? She doesn't have both. Okay. Yeah. Also, a couple of people mentioned when we're writing the truth table, right? When you're doing two variables, P and Q, for P and Q, we're always going to start the same way. So for P, going down, I write true, true, false, false, right? So it's two trues and then two falses. For Q, I start with true and then I alternate. So I go true, false, true, false. Okay, and that's always how it will be when I have two variables. Okay. Any other questions? Somebody's been asking about disjunctions. We will hopefully get to that today. Technically, no. Technically, you don't need to preserve the order in the truth table as long as you give me all four possibilities. It's just usually done this way. Okay. Any other questions on conjunctions, truth tables? Okay. All right, so we're going to next move on to our next type of compound proposition. We're going to talk about disjunctions, as I said a second ago. So again, I'll start with a definition of what a disjunction is. All right, so let P and Q be propositions. Okay. A disjunction is where we combine two propositions to form a new sentence using the word or. Okay, so the disjunction of P and Q denoted by this symbol here. So this V symbol represents the word or. That's the disjunction of P or Q. Is the proposition P or Q. Okay. So P or Q is false when both P and Q are false, and is true otherwise. Okay, so the disjunction P or Q, I wrote here that it's the sentence P or Q. There's really a little bit more to it though. It's really the sentence P or Q or both. I'll put that in parentheses there. Okay, it's just the or both part is usually implied without actually being said. Okay, so the only time a disjunction will be false is when both P and Q are false. If at least one of them is true or both of them is true, then it's a true sentence. Okay, so using the same P and Q as above, I could write the following disjunction. P or Q could be would be the sentence Lisa's car has a backup camera or a sunroof. Okay, and I'll write here in parentheses or both. I'll write it this time, but most of the time we won't write it. Okay, and again, if you want, you can throw in negations into here. For example, I could write the sentence not P or Q, okay, where the not is only on the P there. This would be the sentence Lisa's car does not have a backup camera, or it has a sunroof, or both. Okay, so Lisa's car does not have a backup camera, or it has a sunroof. Okay. I also should mention here at this point, whenever I write a negation, the negation only goes on what's immediately after it. So this is not P or Q, okay? If I want the negation to be on more than that, I'll use parentheses to clarify. So this is a different sentence. This is a different proposition than what I wrote above, okay? Because here the negation is on the entire sentence, okay? This would be the sentence It is not the case that Lisa's car has a backup camera or a sunroof, right? Or you could say it has neither this nor that, right? But let me write it this way. It says, it is not the case that Lisa's car has a backup camera or a sunroof. All right. Somebody asked.
Hello.
Yes, go ahead.
You in the last sentence you wrote care instead of car.
Oh, thank you. Thank you very much. Excellent. Thanks. Okay. Can you use the word either? Yeah, if you want to write either or, that's helpful. All right. Sometimes using the word either will help to clarify if there are parentheses or if there are commas in your sentences. So you can use either as well. Okay. All right. Any other questions on that? All right, so let's write out the truth table for the disjunction P or Q. Okay. Again, I start with my two variables, P, Q, and then the disjunction. Okay. So 4 possibilities. So for P, I write out true, true, false, false. For Q, I alternate true, false, true, false. And that gives me my 4 cases. Okay, remember we said that the disjunction will only be false when both P and Q are false. So in the first case, P and Q are both true. It's true. Second case, P is true, even though Q is false, so it's true. Third case here, one of them is true, it's true. Final case, they're both false. The sentence is false. Yes, that's correct. As long as one of them is true, for disjunctions, the sentence is true. Okay. Okay. Any other questions on disjunctions? All right. So far we have negations, conjunctions, and disjunctions. We could technically combine as many propositions as we want using these tools, okay, these connectives or operators, all right? So I could have a sentence, not P or Q, and Q and R, if I wanted. You know, this would be a compound proposition that has negations, conjunctions, and disjunctions, and there's also 3 variables in here. There's a P, a Q, and an R, okay? And so that could be an example of a compound proposition, and then you can make as complicated a sentence as you want. Okay. All right, so let's now move on to the next type of compound proposition. The next one we're going to discuss is known as a conditional statement, also called an implication. Okay, so let me give you the definition for that. All right, so let P and Q be propositions. The conditional statement or implication, as it's sometimes called, written this way, so that's a P with an arrow pointing at Q, is the proposition if P then Q. Okay, so any sentence of this form, if P then Q, is called a conditional statement or an implication, all right? And it's denoted with that symbol there, a P with an arrow pointing at Q. Okay, if P then Q. If P then Q, that conditional statement, is false when P is true and Q is false, and true otherwise. Okay, so whenever we have a conditional statement, P, the if part of the sentence, the P, is called the hypothesis. Q is called the conclusion. Okay, so P is called the hypothesis, and Q is called the conclusion. All right. So let's look at an example here. Okay, let's say I have a proposition P. Let's say P is the statement, I am elected to office. Q is the statement, I will lower taxes. Okay, so we have here two propositions. If P then Q would then be the conditional statement, if I am elected to office, then I will lower taxes. Okay, so here the hypothesis is the sentence, I am elected to office. The conclusion is the sentence, I will lower taxes. Whatever comes after the word if is the hypothesis. Whatever comes after the word then is the conclusion. Okay? So when will this sentence be true and when will it be false? We said in the definition that conditional statements are only false when P, the hypothesis, is true, but Q, the conclusion, is false. Okay, why? Because a conditional statement tells us that whenever P happens, whenever P is true, Q will also be true. So if P is true but Q is false, then that means the statement is a lie. It's not true. Okay, so we can sort of look at this example here to maybe try and understand that a little better. Okay, let's say that P and Q are both true. Okay, so let's say P is true. This person is elected to office. And Q is also true. So he's elected to office and he lowers taxes. Okay. Then this person told the truth. It's a true statement. He said, if I'm elected to office, I will lower taxes. That's exactly what happened. It's true. He didn't lie. He didn't break his campaign promise. Okay. Let's say now that P is true, but Q is false. So he's elected to office, but he does not lower taxes. Then the statement was false. He lied. He broke his campaign promise. So the statement was a false statement. Okay. What about if P is false, but Q is true? If P is false, then he's not elected to office, but let's say he lowers taxes anyways, right? He's a lobbyist. He goes to the local government and he has them lower taxes. Okay. Then he also didn't lie, right? He still told the truth. It's just that he was never elected to office. He never said what would happen if he was not elected to office. Okay. So his statement was still true. He never lied. He never broke his campaign promise. So that statement would still be considered true. Okay. Let's say P and Q are both false. So he's not elected to office and he doesn't lower taxes. Again, he didn't lie because he never broke his campaign promise. Okay. So the only time conditional statements are false is when P is true but Q is false. Okay. In any other case, the conditional statement would be true. Okay. If you have any questions on that? Any questions on that? Yeah. Right. Again, the only time a conditional statement will be false is when the hypothesis is true, the if part of the sentence is true, but the conclusion is false. Yes, right. So if the condition is met, but the promise is not kept, exactly as you said, then it would be a false statement, then it would be a lie. Okay. All right, so let's write out the truth table for this, for conditional statements. Okay, again, I have two variables, P and Q, four possibilities. So true, true, false, false, true, false, true, false. Okay. In the first case, P and Q are both true. The conditional statement is true. In the second case, P, the hypothesis is true, Q is false. The conditional statement is false. And in the next two cases, the conditional statement will be true. Okay. So conditional statement is only false when the hypothesis is true, but the conclusion is false. Okay. So as we mentioned a little bit earlier, also in English, whenever we have sentences in English, a lot of times they can be written in many different ways or different forms. So a lot of times you can have a sentence in English that's a conditional statement, but it's written without using the words if then. Okay. So there are alternate ways in English of writing conditional statements. I'm going to give you a list of a few of them. Okay, and then you can also find this list in your textbook if you take a look. Okay, so below are some alternate or alternative ways of writing if P then Q in English. We'll get to the homework in a minute. 1 second. Let's just finish with this, and we'll discuss the homework after. Okay. All right. So if you ever see a sentence written in the form Q if P, okay, that's the same. That's a conditional statement. That's the same thing as saying if P then Q. Okay. So in a sentence written in this way, P is the hypothesis, Q is the conclusion. Okay? It's the same thing as saying if P then Q. 2. If you see a sentence written in the form P only if Q, that's also a conditional statement. That's the same thing as saying if P then Q. Okay, so again, P would be the hypothesis, Q would be the conclusion. Another way would be if you have a sentence that says P is sufficient for Q.
Professor,
Yes.
can you repeat the last row of the truth table of PQ conditional statement?
The truth table?
Yeah, the last row that P is false, and Q is false, so conditional statement would be true.
Yes.
Okay. Like, I didn't understand that.
Okay. So again, if you want to go back to the example from before, okay. Let's look at this example for a moment to sort of demonstrate that. Again, let's say the politician, he says, if I'm elected to office, then I will lower taxes. Let's say both of those are false. So he's not elected to office and he does not lower taxes. So did he tell a lie? Right? He never told a lie. He was never elected. He never lowered taxes. So in that case, we since he didn't lie, we label the statement as true instead of false. Okay.
Oh, okay.
It's only false. Right. Oh, somebody's also asking about the exclusive or. We're not going to really do much with the exclusive or. Maybe we'll briefly discuss it next time, but we're not going to really do much with the exclusive or. Okay. Okay. Oh, one moment. Let me go back to this list I was giving you, and let me finish this list here, and then we'll conclude for today. Just give me another minute here. Okay. Number 4, Q is necessary for P. Okay, that's another way of saying if P then Q. So again, if you see a sentence written in that form, then the P is the hypothesis and the Q is the conclusion again. 5, Q whenever P. 6, Q unless not P. And I'll give you one more, 7, P implies Q. Okay, a lot of times I'll say a conditional statement that way. Instead of saying if P then Q, I'll say P implies Q. Okay? All right. Any questions on that?
Sir, could you please elaborate on number 2, please? P only if Q. It sounds really counterintuitive to me.
Number 2, P only if Q. Yeah, sometimes some of them might sound a little counterintuitive. So that's why I give you the list to sort of help you out. Yes. The explanations, if you want the explanations for some of these, we'll go over those next time just because we're kind of a little out of time. We're a little over. So we can go over this again next time. If you want me to explain specific ones, I can do that as well. Okay. Yeah, this list is just different ways to state conditional statements. Okay. All right. All right, so 2 things before we go. 3 things actually. Sure, we'll go over 2 and 4 next time if you like. I believe. Let me see, number 4. No, the 4 there. It's correct the way it is. All right. I mean, I'll double check it, but it's correct the way it is, and I'll if you'd like, I'll explain it to you next time, just because we're over time right now. Okay. Okay. So a couple of things. Number 1, if you can, and again, I'll post this on Blackboard. Please email me a copy of either your student ID or a photo ID. So I can verify enrollment. 2, and if there's any other announcements, including for homework, I will post it on Blackboard. Okay, the homework problems to do. Please try and get a copy of the textbook. Either try to find a digital version online, or you can order a physical copy. If you have any issues with that, let me know. Okay, I'm using the 7th edition, so if you want to get the 8th edition, that should be fine as well. Okay. Okay. What else? Oh, are there any other questions before we finish for today? Don't go yet. All right, so the last thing I'm going to do is I want to take attendance. Oh, my email address is, you can find it on the syllabus on Blackboard. It's just sgoldman@qc.cuny.edu. Okay.
It can be your CUNY ID, right?
Yeah, that's fine.
Okay.
Yeah, any photo ID is fine that you have. Okay. The recording I'll hopefully have up later tonight. All right, if not, hopefully by tomorrow at the latest, it should be up. Okay, that will also be posted on Blackboard. Okay. All right, so the final thing I want to do for today is attendance. So please just write that you were here. Make sure you write you were here. When you write that, your full name appears as well. If you didn't log in with your full name, just write your name. No, my email is sgoldman@qc.cuny.edu without the 101 at the end. Okay. All right. Okay. Once you let me know you're here, you can go if you have no other questions, and I will see everybody next week at this link. All right. Thank you, everyone, and have a good night. Yes, please email me a copy of your ID through to my email address. Yeah. Take care, everybody. Okay. And I'm just gonna wait another minute for anyone else that didn't write they were here yet, and then I'm gonna head out. Okay. Take care, everyone. Have a good week. I will see you on Monday, hopefully. Okay. All right, hopefully everyone wrote they were here. I'm gonna head out.